Okay, so what type of nuclear chemistry is needed for a nuclear bomb to work? Nuclear fission is a process by which the nucleus of an atom is split into two or more smaller nuclei, known as fission products. The fission of heavy elements is an exothermic reaction, and huge amounts of energy are released in the process. The nuclei produced are usually slightly different sizes, typically with a mass ratio products of about 3 to 2 for common fissile isotopes. Most fissions are binary fissions that produce two charged fragments. In nuclear fission, an unstable atom splits into two or more smaller pieces that are more stable and releases energy in the process. The fission process also releases extra neutrons, which can then split additional atoms, resulting in a chain reaction that releases a lot of energy. In order to initiate fission, a high energy neutron is directed towards a nucleus such as 235U. The combination of these two produce 236U, which is an unstable element that undergoes fission. The resulting fission process often releases additional neutrons, which can go on to initiate other 235U atoms, forming a chain reaction. While nuclear fission can occur without the neutron bombardment in what would be termed spontaneous fission, this is a rare occurrence. Most fission reactions, especially those utilized for energy and weaponry, occur from the neutron bombardment. If an element can be induced to undergo fission through neutron bombardment, it is said to be fissile. Atomic bombs are made up of fissile elements such as the uranium that is enriched in the isotope that can sustain a fission nuclear chain reaction. When a free neutron hits the nucleus of a fissile atom like uranium-235, the uranium splits into two smaller atoms called fission fragments, plus more neutrons. Fission can be self-sustaining because it produces more neutrons with the speed required to cause new fissions. This creates the chain reaction. In fission weapons, a massive fissile material, either enriched in uranium or plutonium, is assembled into a supercritical mass. The amount of material needed to start an exponentially growing nuclear chain reaction. This is accomplished either by shooting one piece of subcritical material into another, termed the gun method, or by compressing the subcritical sphere of material using chemical explosives to many times its original density, called the implosion method.